Once again, my name is Al Palmer. I'm from Montcalm Community College, and I'm going over some of the material that is covered in the AMATROL learning activity packets. And the last 4 skills that you have to show the instructor involve connecting the power supply to 4 different devices. And they're not really specific, but I want to make a point that these devices are chosen for a reason. They have specific operating voltages and types of current that they run on, alternating current or direct current. So the very first one says a resistor, connect up on a resistor. And a resistor's job, basically, if you want to say that, is to turn electricity into heat. That's all they do. And they limit the amount of current that can flow through a circuit. And the current that flows through is turned into heat. As I talked about in the previous learning video, when you talk about the RMS voltage, which is the same thing as volts AC, you have the same effective heating value. So if I was for AC as you do for DC, so if I was to connect this resistor to 12 volts AC, it would draw 1.2 amps because that's 12 volts divided by 10 ohms. And if I hooked it to 12 volts DC, it'd be 12 divided by, it'd be 1.2 amps. And it would generate the same amount of heat whether this was running on AC or DC. So resistors are electronic devices that are don't care whether they're connected to AC or DC voltages. Now, when you get into other things, then whether you're hooking up to alternating current or direct current becomes critical. So I'm going to hook this power supply up, and I'm going to hook it up to direct current. And we've put banana plugs on our leads, and we've converted all of our connectors on our loads to also banana plug adapters so they can be hooked up directly. Now, one of the things you're supposed to hook up is a motor. That's fine. This is a specific type of motor. It's a brushless DC motor. It's basically a computer fan. These things are polarity sensitive, which means if I hook it up backwards, it's not going to run. So these are designed, everything on the board here, it can be hooked up to either AC or DC. It can be hooked up on DC frontwards or backwards. You can't burn out anything on this board. I've never had anybody be able to do that. But that doesn't mean they're going to work. So when I hook this up, there is a plus and a minus. So I'm going to hook the red wire to plus and the black wire to minus, and the fan will turn on. And it's running. And if I connect this middle connector from 0 to minus 12, now I'm connecting the fan from minus 12 to plus 12, and the fan runs a lot faster. This is actually a 24 volt fan, so it runs fine on 24 volts. If I connect this fan up backwards by connecting it to the middle lead and connecting the positive lead to the negative 12, which is still red, they've kind of labeled this weirdly, this fan will not run because brushless DC motors have transistors in them, and transistors do not work when they're hooked up backwards. So this fan will only run when the polarity is correct, and it runs much better when it's hooked to the correct voltage. So this is a polarity sensitive fan which will not run on AC voltages at all, and runs much better when it's connected to the proper operating voltage. I think in the lab they tell you to run it on 12, but it doesn't hurt it to run it on 24. Now, one of the other demos I wanted to show you, this is the solenoid. You can hook the solenoid. The solenoid runs much better on DC than it does on AC. So if I turn this on, flip it to AC, the solenoid is trying to draw this magnetic bar in, and the bar pulls a little bit, doesn't have a lot of strength. If I flip this over to DC, there is no way to get this bar out of here at all. And all I have to do is shut the power supply off or disconnect it, and the bar comes out very easily. This is a very powerful magnet when it's hooked to direct current. Even if I only hook it to 12 volts instead of 24 from 0 to plus 12, it's still a very powerful magnet. And polarity is not an issue. If I hook it up to 0 and minus 12, it just magnetizes it the opposite direction, north pole instead of south pole. Still can't pull it out, shut it off, comes apart very easily. So this is a DC works much better on DC than it does on AC, but polarity is not an issue. I thought one of the more interesting loads that you can hook to this is the buzzer. And the buzzer is hooked, it's labeled plus and minus. We labeled it that way. If you hook it to plus and the minus to minus, the buzzer beeps. Now, if I hook it up backwards, take the red lead, put it into minus 12, buzzer doesn't buzz. Once again, it's a transistorized circuit in here. Transistors don't work well when they're hooked up backwards. But here's an interesting thing. Watch what happens when I flip this to AC. You noticed before when I hooked this up backwards, it didn't work. Frontwards it works, backwards it doesn't. When I flip it to AC, the alternating current is going positive, negative, positive, negative. You'll actually be able to hear this buzzer only buzzing on the positive voltages. That's a 60 hertz buzzer. The buzzer is actually working at around 400 hertz, but it's on, and then when the signal goes negative, it shuts off, and when it goes positive, it turns on. So you're actually hearing the buzzer turn on and off 60 times a second. If you could count really fast, you'd hear this buzzer buzzing exactly 60 times in 1 second. Thanks for watching.